Okay.
Yes, Akshara, you can start.
So, hi everyone. My name is Akshara Gupta and I'm an 11th grader. So, today we're going to talk about a really interesting topic. But before that, I'd like to get to know you guys. So, if you guys could please tell me your name and which class you are in. Hello, am I audible?
Yeah, you're audible. Yes, Sejal.
Yeah, go ahead.
Hi, Akshara. Good evening. I'm Sejal, and last year only I completed my graduation, and currently I'm doing a fellowship.
Oh, that's wonderful. Nice to meet you.
Me too.
Yeah, Sanya, go ahead.
Hello, I am Sanya and I have recently graduated with a degree in financial management and I am looking for a job right now. Thank you.
Oh, that's nice. Great to meet you. You can unmute your mic and speak. Like you don't have to wait for your turn. Don't worry.
Okay. Hi, Akshara. I'm Kushagra. I'm in second year BCom.
Oh, okay, nice to meet you, Kushagra.
Hello, I am Sakshi and I am stepping into my TYBSc, please.
Okay, that's great. So it's wonderful to meet you all. And just one small request. Be active, okay? Ask questions and answer questions and don't hesitate, okay? At all. I can see that I'm younger than you all. So I really hope that this will be a fun interaction. First of all, yeah, please give me a minute. Um, okay, so we're gonna start with the video. So let's see what it's about.
Akshara, is there supposed to be sound in the video?
So, you see, you guys, what did we see in the video? Michael Jordan, he dunks like in basketball, but he requires physics for that. He needs to see at what angle, and he dunks at a 40-degree angle, right? So he needs physics for that. Similarly, social media, it's a technology again. We require technology for it. I'm conducting this meeting, this discussion with you all, and we require technology for it. Robots, have you guys seen the movie called Transformers? Has any one of you seen it? Yeah, you have. So, that movie is about robots transforming into different, entities like cars and all that, right? So, again, that was in movies, but now it's reality. People are using robots. And all this would not have been possible without STEM. But what I've seen is that there are a lot of people, and we could use more people in STEM because we need more ideas. And most of the population who choose STEM as their field are males. So I'm here today to motivate, to encourage you all, especially the girls over here, to choose STEM as a career option because we really need you. Now, let's get into a few questions. So the first question is, what is STEM? You can unmute your mic and answer. Am I audible? Yeah, go ahead, Sanya.
It's
Technology, engineering,
science, technology, engineering, and maths.
Yeah, so option C, you're right, it is. And at what angle does Michael Jordan dunk? Yeah, Fatima?
C.
Yes, 40 degrees. You're right. Now, let's play a little game, okay? In your mind, you should form an image of a person, like from a particular profession. First is doctor. So that person has to be a male or a female, okay? So the first is a doctor, second is engineer, third is nurse, fourth is teacher, and fifth is scientist. I'll give you a minute and then just tell me, whom do you think, a male or a female, okay? Have you thought about it? Yeah, Sejal, go ahead.
Okay, so as I was thinking, I was just remembering people who are in these professions.
Yeah.
And as we have normalized in society that male are supposed to pursue this field and female are supposed to pursue this field, I was able to think all of those things. For example, for doctor, I remember one doctor who is a male, and I could remember of a female as well. But first I thought of a male doctor, and then for engineer, I could think of a male. For nurse, I thought about my mentee who's studying to become a nurse. And for
Oh,
teacher as well, I thought of my teacher, who was a female. And for scientist, I thought of a male that I think recently saw on a review.
yeah. So, so if you see, like all of us think the same, right? So we've all thought of males in the fields such as doctor or engineer. So these are like scientists. So these are the fields of STEM. So I'm here to change this mindset, to inspire you all to get into these fields because they are wonderful fields with great opportunities. Okay. Now I'm gonna show you a few pictures of like, males, and they're like kind of popular. So in all fields, okay? And let's see how many of them you're aware about. Does anyone know him? Have you guys seen him? Yeah, Sage.
Yes, he's Stephen Hawking. He was into news a few times or few days ago.
Yes,
So
yes, you're right. He's Stephen Hawking. And anyone know who this is? Yeah, Sejal, you don't need to raise your hand. You can just unmute your mic and speak.
I'm not sure, but is he Dhirubhai Ambani?
Yeah, you're right again. And what about him? Oh, wait. Yeah. Sanya, I think your mic is, yeah, it's muted. Yeah, go ahead.
Yeah, he is APJ Abdul Kalam.
Yes, you're right. And what about him? Can you see the apple falling from the tree? Does that remind you of gravity? So, any guesses?
Albert Einstein.
Sorry, what?
Albert
No, Albert Einstein did not, in fact, discover gravity.
Isaac Newton.
Yes, you're right, Isaac Newton. And what about him? Does anyone know him? No? It's all right. He's C.V. Raman. And what about him? Anyone know him?
I guess Bill Gates.
Yes, he's Bill Gates. You're right. And him? Yes, Anya, you're right. I think you're right.
So which I guess
Yes, you're right. Good job. And what about him? I think his name was
I
said
think,
earlier.
yes, I think he is Albert Einstein.
Yes, he is Albert Einstein. So you see, we knew almost all of them, right? So now I'm gonna show you the pictures of a few females, and let's see how many of you know them. Does anyone know who she is? You know, I'm sure you've heard of her. She's a Nobel Prize winner. She even discovered radioactivity. Does anybody know? No? She's Marie Curie. Does anyone know who she is? I'll give you another hint. She's known as a human calculator.
Shakuntala Devi.
Yes, you're right, Shakuntala Devi. And anybody know her? Here, I'll give you a hint. So, I don't know how many of you guys have studied from the CBSE board or if you've referred to NCRT textbooks, but there's a chapter in grade 9, A Truly Beautiful Mind in NCRT, and that chapter is based on Albert Einstein, and she is Albert Einstein's first wife. Anybody? No? Maliva Merrick. So, did you see the contrast? Did you see? We knew all the males, but we knew only a few, like only one female, right? So, that's what I want to change. So, let's get into a few more questions. So, who discovered gravity?
Isaac Newton.
Yes, Isaac Newton. And what did Marie Curie discover?
Radioactivity.
Yes, you're right. Radioactivity. Now, who gets to do STEM? So, the whole point of this picture activity, as I mentioned, was to show you that the male scientists or males in any field are very commonly known, like Albert Einstein, Isaac Newton. We hear them like when we think of science, they're the first people who appear in our mind. Now, Marie Curie or Maliva Merrick, do they? They don't. Why? Because their examples aren't given. Some people might know that Marie Curie won a Nobel Prize, but do we know how they actually look like? And the main reason I thought about this because I'm a teenager and I am living in a world where I can see that in my school, only 25% of the girls have opted for STEM related courses, and 3% of the girls have opted for computer coding courses. So, do we think that number is enough? Do you think it's enough? Like, yes or no? No, it's not, right? So let's see why and where do girls drop off. So it's around middle school in 6th to 8th grade and sometimes like 9th and 10th grade. So when we have to choose our streams, fewer girls go into the science streams. Their participation in math and physics drops. And this is because of the confidence that starts declining because of society, right? About 50% of girls, they are making up the total school enrollment. But as I mentioned, only 25% of them are taking STEM related courses. Now, there are only 43% girls at undergraduate levels, and there are only 20% of the supernumerary seats reserved for women in IITs. And did you know that it was bumped from 10% to 20% just because women weren't participating or they weren't getting enrolled into IITs. Like in science, it's still okay, it's acceptable, but in the field of technology, the situation is really, really bad. So now I'm going to show you two pictures, and again, I'm going to give you a minute to interpret them, and like whatever you understand from these, just say, let me know, okay? So, did you guys think about it? Yeah, Sejal, go ahead.
Thank you. So there are multiple thoughts that came across my mind. First, image shows like what it should be. There should be equal number of women and men, maybe, or the women should be given opportunity, at least
Yeah.
in every field. But the second image, like what it is presently, part, I was having multiple thoughts whether it is showing that uh, the work of three women is done by a man, which is also normalized in society. That why should we hire three women or why should we hire women when one man can do everything, sort of
Yeah.
thing. Whether it was that or like that was first thought that came across my mind, and second one was like was it related to enrollment of women in different fields? Like I was thinking about that.
Yeah, so you are like your answer is great. And so yes, this is what I thought about. Does anybody else want to give a try? Sejal, you're right. Don't worry about that. But anybody else who thought of something different, Any ideas? No, it's all right. So, yes, Sejal was right. What I wanted to represent through these pictures was the equality. In the first picture, another thing, if you notice, they are young boys and girls, like a young boy and girl, right? They're kids. They have not fallen into the trap of societal norms, right? They are still thinking, they're curious, they're opening their mind to new thoughts, right? And they're equal. But in the second picture, if you notice, those people are already in, like they're working. They've chosen their fields and their careers. So in this shows the gender imbalance that grows as we, become like older, and when we fall trapped to the societal norms. Like, I don't know, like, does anyone want to share an experience of, hearing that girls aren't supposed to get into the field of STEM, or that, like Sejal said, right? So, anybody have an example they're comfortable to share? It can be about you or, anyone you know, if you want to share. Yeah.
So I don't. I have not pursued STEM field, but I do have some peers who are pursuing it, and they have been told multiple times that like, do you have brain to think about the things that you are studying? Like, are you capable enough to even pursue the field? So there are a lot of bully that they have to go through as they are studying, which also affects their confidence, and then it becomes a
Right.
trap.
Right. So their confidence is being affected, and that'll lead to them not being able to pursue anything further, right? Which is again leading to the decline of women in the field. So this is exactly what's going on these days. Now let's look at another video of a very inspiring lady. She excelled in the field of STEM, and she is inspiring other young girls. So let's look at what she has to say.
There is a lot of misconception and misinformation here that girls cannot do a lot of stuff, girls cannot be independent, girls cannot study science, and there is a particular age when the girls has to get married. So there are so many things which are associated with girls, but then in my case everything was totally different. girls are so motivated and they sometimes come and tell me, we want to be like you, but I want them to be like themselves and just be independent and be fearless. That's the first thing. You have to be fearless.
So you guys, when I saw this video, I felt so inspired and motivating. It was such a nice video. You just need to be fearless. You just need to be independent. And I know you guys will do great. Now, let's move on to another question again. So, what is confidence?
Believing in yourself.
Yeah,
Being
you're right, believing in yourself. So, confidence is not natural, it is taught. As Sejal mentioned an example of their confidence declining, right? So, there was a research in which when some both boys and girls, they had to solve some problem, right? And boys thought that they didn't try hard enough, but the girls thought that they're not good at this. Why? Because from an early age, it is said that boys are smart and girls are beautiful, right? So this leads to different mindset. One mindset leads to trying again, while the other leads to stepping back. So are role models important? Do you think that like when we look up to someone, I'm sorry, and we feel more inspired to do something?
yes, we do.
Yeah. So why don't we all work together as girls and even boys to become role models for the future generations, right? Now, possible reasons for low participation, societal expectations, right? Women are expected to look after the household. They're supposed to raise their family. Another thing is marriage, that young girls, they're married really early. And then there's a concept of dowry still existing in some parts of India, which need to be eradicated, but they're not. And this leads to financial burden. So parents might think, let's save money for their dowry rather than spending on their education. And one of the main reasons is gender stereotypes. Like they literally said, as Sejal mentioned, do you even have the brains for it? What do you mean? Boys and girls are equal, right? But the situation is not as bad as it was earlier. There have been changes in the curriculum. Like over here, I'm showing the CBSE curriculum, right? Earlier, only male scientists, like the book was full of examples of male scientists, but certain women have been introduced, like Asima Chatterjee and Janaki Amal. Does anybody know who these are? Like, just like a one word or two word answer. You've heard of them?
I don't remember actually whether we read about them or not, but I have not read or heard about.
Oh, okay. Anybody else? No? Okay, so Asima Chatterjee is basically an Indian organic chemist, and Janaki Amal is an Indian botanist, right? So this is a great step by CBSE, I must say. But is it enough? So what I said today, what I meant was that there is talent everywhere, right? But the opportunity is not. I gave you an example of Maliva Merrick, if you remember, Einstein's wife. Now, I don't know, but it said that Einstein stole a lot of Maliva Merrick's ideas. But nobody paid attention. Why? Because she was a female. She doesn't have the brains to think of such complicated equations, right? But there have been certain schemes and programs introduced by various governments to, motivate women to get into these fields, like Tamil Nadu's bicycle scheme or Karnataka's Kali program. So it has increased girls' school attendance, and when they are coming to school, it means that they're studying science, and that opens their mind to more critical thinking. So, this is a really, really important step. There is another scheme which is called Vigyan Jyoti scheme, which provides visits to labs and institutions. And think that a girl who has only seen science in textbooks versus a girl who sees it in a lab, there's a huge difference. Now, there are certain scholarships for this, since data was showing that girls were dropping out of science scheme. So, scholarships, we all know, right? They provide financial support, definitely. They also provide recognition and encouragement. So, these are certain programs and scholarships. Now, I'm going to say the name of few more scholarships in India. These are for girls. I'll be coming to the boys too, the gender neutral ones. So I'll be waiting for a few minutes if you want to note down anything, right? I will also be sharing a document of these scholarships with you. Okay, so don't worry about it. You'll have them after the meeting is done. Okay, so the first one is Vice Kiran flagship program. There's another Sir Power scheme. Then Technology Development for Women, AICTE Pragati Scholarship, L'Oreal India for women, young women in science, and Wing Scholarship. Do we know the leading IIT right now? You know, one of the top 10. Which is said to get, like, it's very hard to get into.
I think it's Ahmedabad, or am I off?
Yeah, I think it falls somewhere in the top 10. I'm not 100% sure, but one of the most wanted right now is IIT Bombay. Wherever we go, we're like computer science and IIT Bombay, right? You guys must have heard about it. So they are providing 100% tuition support. And this is starting in 2026. Like, look at how big this is. You just need to study. And I'm telling you, you guys will be able to do great. No, why only go, like, let's go abroad. The sky's the limit. So these are a few global scholarships, okay? The first one is British Council Women in STEM Scholarship. Then there's an Indo-US Fellowship for Women in STEM. Then there's Empower Women in STEM Scholarship, which is for US and Canada. Then there are a few more notable STEM scholarships like Google Women Tech Makers Scholarship or Microsoft Women Scholarship, Adobe Women in Technology Scholarship, and AAUW Fellowships. Now let's look at a few gender-neutral scholarships for both boys and girls. The first one, these are Indian scholarships, okay? So the first one is Central Sector Scheme Scholarship. Then we have the National Scholarship Portal Schemes. Another one is Reliance Foundation Undergraduate Scholarship. Then we have some PSU or like corporate scholarships like ONGC Scholarship or NTPC Scholarship, IOCL. And then there is like some postgraduate scholarships because there were some people who are completing their graduation, am I right? So there's AICTE PG scholarship for MTech students. Now, there are certain gender neutral overseas scholarships, like global scholarships, right? So the first is DAAD scholarship for Germany, Empower Scholarship, Gates Scholarship, Corona Program, SN Boost Scholars Program. So these were a few I knew about. If there are any that you want to share about that you know about, that'd be great. Otherwise, do some more research on these. I know that there are a lot more, and there's a great opportunity. You guys, we just need to study. Financial eligibility will come with marks and you'll get the scholarship and then the ranks. That is all we need to do. At the point of today's session, I am not excluding the boys at all, okay? Boys, you're interested in STEM, get into that field. But I'm here to even motivate and encourage the girls to get into this field because, as I mentioned, I could show you only 3 pictures of women, out of which we didn't even know half of them, right? So that was the point of today. And there are a few women who have achieved a remarkable feat, right? Like Divya Tyagi. She solved a century-old wind energy equation. Then Shakuntala Devi, she's a human calculator. Asima Chatterjee, she works on medicinal chemistry. Kalpana Chawla, I'm pretty sure a lot of us have heard about her, right? So she was the first woman of Indian origin in space. And Ritu Karidal, she contributed to India's Mars orbiter mission. Now, another video, again, let's see what this video is all about.
North Star! স্টার ওরে বাবা তুই তো বড় হয়ে অ্যাস্ট্রোনট হবি সত্যি হ্যাঁ আমি কি হব তুই তুই হবি স্টার বড় ফিল্ম স্টার आपके भाई या पापा कोई है बताओ क्या हुआ वो भी आके मुझे ही बताएंगे राजू दिस इज फैंटास्टिक वर्क प्रिंसिपल मैडम को अच्छे से प्रेजेंट भी करना पड़ेगा क्या बोलोगे This windmill is. This is actually a model of a wind turbine, and it's powered by a motor of this old toy car. And we made this to emphasize that we must switch now to wind energy. How's the class doing for it? So hot for me. Huh? പിന്നെ കഴിഞ്ഞ വർഷം പഠിക്കാന്നാണ് सब तुमने बनाया है सबकी बेटियां प्रिंसेसेस और फेरीज बन के आएंगी और उनके बीच में मेरी बेटी डस्टबिन कैप पहन के रोबोट बन के खड़ी रहेगी कैसे लगेगा बोल पापा मैं करूं मुझे पता है मैं कुछ फोन पे डेकोरेशन चेंज करूं तुम्हारे कपड़े गंदे हो जाएंगे अंदर अच्छे
So, if you guys noticed, these were girls from all over India, right? They were speaking in different languages. And over here, you can see that only 14% of the workforce is in STEM. That is not a good number. So, this is due to gender biases and stereotypes, and that's why I was here today to show you what you can be. And who do you want to be? You want to be a doctor, or you want to be a coder, or you want to be a chemist and live a good life, right? So, go girls. And I really hope that I could inspire a lot of you today. So, if you have any questions for me, please do go ahead. Thank you so much for the hearts, everyone. So it was great interacting with you all. I was so happy with how responsive you were. I think now I'll hand over the mic to Ananya. It was great to meet you.
Thank you.
Can I start?
Yes, you can start.
A minute. Okay. So hello everybody. I'm Ananya and I'm in grade 9. So today I'm going to be talking about F1, which is car racing, and the science behind that. So I'm really interested in sport and STEM, and this is a great way to bridge it both. Okay, so how many of you has anyone watched car racing before? Any sorts of racing? Anyone? You guys can unmute. Feel free to unmute. You don't have to raise your hand. It's an open session. So, okay. So, how fast do you guys think the car on the road can go in about 10 seconds? How fast? You guys can unmute.
300 meter.
Okay, so it goes to about 0 to 100 kilometers per hour in 10 seconds, but a Formula One car does that in under 2.5 seconds. That's like 4 times faster than your casual road car. But why can't road cars do the same? Why can't they be just as fast? We'll find that out because the answer is all in science. Okay, so today we're going to be focusing on three main things. One, to think like a car designer, to understand the science behind the car design. Two, think like a race strategist, that is to be able to plan the race, to know when to do pit stops. Does anyone know what a pit stop is? Has anyone seen a pit stop before? Like when they change the tires? No? Okay, I'll show you. And use science in real life because Formula One racing is a sport and a lot of technology is involved in it. Okay, so how many of you like running fast, driving fast? Everyone likes going fast, right? So, so speed is everywhere around us, but we also need to be able to use speed smartly. So when you're playing tag or you're playing like chase, what happens is when you're turning, you tend to slow down more than when you're running in a straight line. And the same way works for cars and bikes as well. So when you're going in a straight line and not turning, your speed is faster than when you're turning, it's a bit slower. So I'll play a clip. This is of a it's a clip from a race. So I'm just gonna play it. Okay, so that's an overtake, and it's just a small clip just to get you into the sport and how it works. Okay, so now let's actually get into what makes these cars so fast. So I'm going to show you something through my video. Tell me if you guys can see it. Can you guys see the car? You guys can
Yes.
thumbs up and go. You guys can see, right?
Yes.
So there are two main forces that work on a car when it's going on a track. So it's called drag and downforce. So drag is basically like air resistance. So think of air like small particles around the car. What the car has to do to move is you have to move away this air particle. So it's like a wall that's blocking. So let's say you have a wall, you have to break that wall to be able to move further. So this is the same thing what the car does. So what happens is there's air and the car has to break through the air. So it makes a hole in the air to be able to go faster. But this air is going to push against the car, right? So what the air is doing when it pushes against the car, it's like adding extra weight to the car. So it makes it slower. So when the air pushes against the car, it slows it down. So this force that the air is putting on the car is known as drag force. So what is the force that's acting on the car, which is pushing against it and making it slower? It's called drag. And the second force that acts on a F1 car usually is called downforce. So what downforce is, it's like, so for a car to be able to drive on track, it needs to touch the track. It needs to stay on the track, right? So without downforce, what will happen is the car, it will fly off the track. So the point of downforce is the air to push down and make sure it's on the track. So if the car has more downforce, it gets better grip, so it can turn faster. So if you, for example, if you put your hand out the car or if you put your hand out the bus, you can feel the air pushing down on your hand, right? So that's downforce. So what happens is the front bit of this car and this back bit, it is what generates the downforce and allows the car to stay on track, helping it turn easier and faster. So these are the two forces that act on a Formula One car usually. So I'm just gonna get to a few terms. Does anyone know what a track is? So, does anyone know what a track is?
May I
So,
guess, please?
yeah, go ahead.
Yes. So uh, it's a line, not a line, but a track is like it is very similar on what we run. That even that is called a track.
Yeah, Shakra, you can go ahead. You don't need to raise your hand. You can just unmute and speak.
Like it's a road for F1 cars, like it is like Jalebi Road something.
Yeah, that's nicely explained. Okay, so along the same lines, does anyone know what a lap is? Yeah, you can go ahead. Yeah, you can unmute and go ahead if anyone knows. Does anyone know what a lap is? No? Okay,
If we cover one the if we complete that same route again and again, it is called a lap, like first lap, second lap, third lap.
yeah, exactly. So he explained that well. So a track is the road on which the cars drive, and a lap is going around that road once. So you start at a point and you come back. So that's one lap. So in an F1 race, usually the cars do 50 to 70 laps around the same track. Anyone know what a pit stop is? I already asked this. A pit stop. Okay, wait, I'll show you a clip of a pit stop. 1 second. Okay, so this is a pit stop. I'll just play it. So, did you guys understand what a pit stop is? Can someone explain it? Like, what did you see in the video? Okay. So a pit stop is basically what happens is when the drivers are driving around the track, what happens is because of the friction between the tires and the road, the tires start to wear. So basically they start losing the grip and they it makes the car go slower. So what they do is the cars they come into a separate road where people change the tires, and this is really fast. So these guys are really fast and they're skilled at doing this. So they change the tires within 2-3 seconds. So all four tires get changed within 2-3 seconds. So it's incredibly fast. So in an actual F1 race and how the engineering works is you can either have more downforce or less drag. So how this works is if you want a lot of grip, that'll make you slower because you're getting more air resistance. So that means that you're getting better grip, but when you're going straight, you're going to have less speed because there's more air resistance. But on the turns and the corners, you're going to have more grip. But or you can have less drag. What less drag? It basically means you're very fast when it's straight, but when you turn or when you're taking a corner, what happens is there is less air resistance, so you're slower on the corners. But what happens is in an actual situation is you can't have both. So you can either have more downforce or less drag. So let's see this with the example of two tracks. So these are two tracks. One is in Monaco and one is in Italy. So can someone tell me the difference in between the two tracks? Can you see it? It's on the screens here. Can someone?
Yes.
Yeah. So do you know can you observe the difference in between the two tracks? Look at the number of turns, look at the number of straights, like straight roads. Do you see a difference?
Yes, there are more turns that the person has to take in first picture.
Yeah.
And the second one, as compared to the first one, has lesser turns.
Okay. Anyone else? Okay. So basically, you're absolutely right. In the first track, there are more turns. And in the second track, there are more straight lines, straight roads. So let's think with respect to the forces we learned, downforce and drag. So when there are a lot of turns, you want more grip. So technically, does anyone remember what I said about having more grip? Do you need more downforce or less drag? Can someone tell me? Downforce is what gives you grip, and drag gives you like more speed in the straight lines. So if I want more grip, what do I use? More downforce or less drag?
More downforce.
Exactly. So when there are more turns, you want more grip. So that means you need more downforce. And for example, in the second chart, there are more straight lines. So I don't need necessarily more grip, but I want to be really fast on the straight roads. So what do I need? More downforce or do I need less drag? Do I need better grip or do I need to go faster in the straight line? If someone can unmute.
We need to go faster on the straight track.
So do you need more downforce or less drag? Downforce gives you grip, drag gives you more speed. So less drag. So if I want to go faster, I will need more downforce or less drag. I need less drag in this case. Okay, so moving on. So did everyone understand downforce and drag, or do you want me to explain it once more? Should I do it with the respect of the... You guys can unmute and talk. Did you guys understand it? Do you want me to reply it once more? You got it? Okay. Okay, so basically in tracks which have more turns, I will need more downforce because it gives me more control and it grips the road. So it gives me better grip, and that's why I need more downforce in tracks with a lot of turns. In tracks which has a lot of straight roads, I need more speed and so less drag. That makes me faster on the straight roads. So that's basically on the engineering side. Second thing is called strategy. Does anyone know what strategy is? Strategy. Okay. So basically what strategy is, okay, you can answer. Sejal, you raised your hand.
Thank you. Strategy is planning.
Uh-huh. So how do you think that works in a car race? Anyone wants to try? It's planning, exactly. How do you think it works in a race situation? Does anyone know?
Yes, please. So if there are more, if I have to take more turns, then I have to decide accordingly that do I need more downforce or less drag, and
Exactly.
accordingly I'll choose and plan and execute it.
Exactly. Kushagra, you raised your hand.
Yes,
Yeah.
please. So if if the driver is thinking to do like in first, like you told us, like in F1 they take 50 to 40 laps in
Yeah.
the same track. So like for the first 10 laps they could have a speed limit like for so much or this much kilometer per hour, and then after completing 10 lap they can increase that kilometers. It could
You're
have that planning.
Yeah, okay, you're going on the right track. So I showed you guys a pit stop, right? So a similar thing happens in a race. So let's think of tires. So tires, you guys know what friction is, right? Yeah, so friction, someone can unmute and tell me what friction is? The friction force. Does anyone know? Oh, okay. So everyone rub your hands together. Can everyone rub your hands together? So when you rub your hands together, what do you feel in your hands? If someone could unmute and tell me what will happen when I'm rubbing my hands together, what do I feel in my hands? Doesn't it feel warmer? Right? And so why it feels warmer is because of the force of friction. So when any two things rub together, there's friction. And eventually, when two things rub together for too long, it'll get really hot, right? So now these tires are going around and around and around. So there's a lot of friction in between the road and the tire. So let's think of the tire to have something like a battery. Okay, so everyone knows in your laptop battery or phone battery, when it has higher battery, it works a little faster, right? So it's somewhat similar like that in the tires as well. So once the tires have worked for a lesser amount of time, so if they've done fewer laps, they're faster. But when the tires have done more amount of laps, eventually, because of how much friction is getting caused, they actually become slower. So do you understand what strategy could be used like in that way also? So you can use more than one tire in one race. And that's why you do pit stops. So when you use a tire for too many laps, because like you have to do 50 laps. So if you use one tire for too many laps, you'll get very slow. Understood? So why you need strategy is whether you can either, when you do a pit stop, what happens is you lose time. So if I'm second in the race and I do a pit stop, I might come down to third place or fourth place. But if I don't do a pit stop, I might stay in second place. But what will happen when I do a pit stop is I'll be a little faster than the other people. So I can overtake and get back to second place. So that's how it works. So there are actually 4 types of tires. This is just for information. So in F1, depending on how long the tires can be very fast, there are 4 different types. I'll play a video for you to understand.
Now, have you ever wondered what makes a Formula One tire
Can you hear?
Yes, it is on.
Okay. I'll just...
so special? Well, it's all about the compounds. On any given race day, drivers can select from soft, medium, and hard compounds for dry weather conditions. But what's the difference? Soft tyres are the fastest but wear out quickly. Medium tyres are the compromise, offering decent performance and endurance. Hard tyres provide the least grip but last the longest. There are also compounds for wet weather. When racing in serious rain, drivers use the full wet compound marked in blue. And for a damp, in-between track surface, there's an intermediate compound marked in green. So next time you watch your...
Okay, so I'll also explain it once more. So there are 4 different types of tires. So soft tires, think of it as a battery. So what happens in soft tires is it has very little battery. So it's very fast for only a very short amount of time. So what soft tires do is they're the fastest among all the different tires, but it can only be very fast for only about 15 laps. Medium tires is they're not as fast as the soft tires, but they last a little more. So they can do about 25 laps. So they can do more laps than the soft tires. Now hard tires, they basically they're very slow compared to the medium and soft tires, but they can last very long. So what the soft tires do is they give you very fast but short amount of time. Medium tires, they're not very fast, they're fast, but they last for longer amount of time. And what hard tires do are they're not the fastest, but they actually last for a very, very, very long amount of time. So, but when it rains, what happens is the track becomes wet. And because of the track being wet, we use special types of tires called intermediate tires. And these are just for rainy conditions. Okay. So let's do a sort of an activity now. So it's like battery. So we're going to do, I'll give you a situation and you guys have to tell me when to pit, whether to pit very early or to pit too late. So to give you guys an idea, if I'm third place in a race and I pit, what will happen is I'll come down to 5th place, but my tires will be faster so I can overtake better. So if I'm third in a race and I pit, what will happen is the tires will make I'll get new tires and that will make the tires faster and I can overtake easier. Or if I don't pit, I will stay in third place. But if the car behind me pits, they'll get faster tires and they can overtake me. So did you guys understand? I'll repeat that once. So if at all I'm in third place and I pit, what will happen is I will get faster tires and I can overtake easier. But if I don't pit, the car behind me will get faster tires and they can overtake me easier. So I will come to 4th place and they'll go to 3rd place. So we'll try and do that ourselves. So now you guys are going to tell me what we have to do, whether we'll pit now or we won't pit now. Okay? Did everyone understand? Okay. So let's start. So you guys are in a race and you guys are 25 laps you guys have done. So what is going to happen is rain is going to come. So when rain is going to come, either I'm going to get the tires which will make me fast in rain. The rain hasn't come yet. We think rain is going to come. So I can do three things now. I can either do a pit stop and get the tires which are going to make me fast in the rain, or I can wait for the rain and then change into rain tires, or I can just stay on the tire I'm in so that I can do overtaking and instead of losing time while pitting. So you guys can do anything. So if you have to do something, what would you do? Anyone can raise their hand and answer. Will you do a pit stop now or will you wait for the rain? You guys can raise. You can unmute your mic and tell me. Yeah, go ahead.
So I think I would go for option A, pit now, because I already know that there is a potential risk of rain, which may affect my performance in the race. So it's better for me to be already to already take precautions, like to already change tires so that I can overtake.
Yeah, okay, that's very well said. Um, so this is what will happen. So if you pit now, you lose time now, but you get the correct tires. But if you don't pit, your tires will get worse and you will eventually, other cars will overtake you. So that was the right decision. So good job. Okay, so let's make another situation. What happened was the rain has not started yet. So the rain hasn't come, but your tires are very slow. So let's say in a way the battery has come down and the car behind me is catching up. What can I do? Should I get new tires now and be faster than my opponent? Or do I stay and just hope that my opponent doesn't catch me? So what do I do? Do I get faster tires or do I wait? Yeah, go ahead.
Pit now,
Yeah, exactly. Why do you pit now?
because so my opponent, so I will go ahead of my opponent.
Exactly. Right decision. So that so basically that was your own decision, but there is no right or wrong. We don't know what's going to happen later. So we just have to guess. So we have to hope and we have to use all the data we have in our hands and we have to try and make the right decision. And there isn't always a wrong answer. So all the answers you gave were great. So thank you for being so interactive. Um yeah, you guys were great. Thank you. Any questions from anyone? Anything? Okay, we're good. Thank you.
Thank you.
Thank you, everyone.
Thank
If
you,
anyone has questions, they can ask Ananya and Akshara. And if anyone wants to say anything they liked about the session or have anything to discuss, they can do that as well.
Yeah, Sejal. Yeah, go ahead.
Thank you. No, I just wanted to take this time and thank both of you for such an interesting class. I think we all had fun and we all enjoyed it. Thank you.
I'm so glad, and I could see that you guys enjoyed a lot. Like you guys were responding. Yeah, go ahead, Sanya.
So thank you, Akshara. Like, even I was not aware that I didn't know the names of women, and like, so thank you for that, and thank you for letting me know that. Ananya, thank you for like, it was interesting. F1 car, I have seen like thoda sa video, not much, but yeah, it was good. Thank you.
I'm happy to know you had fun.
Yeah, me too. There's one more thing. If anybody wants to reach out to me, I'm sharing my email in the chat. So you can reach out to me anytime and I'll get back to you. Okay, so I hope everyone can see it.
Also, I think Ananya has a brochure she wants to share with everyone.
So
So,
do I
Ananya,
attach
sorry,
it? Do I just attach it on the chat? Will that be fine?
yeah, you can attach it to the chat so that
Okay.
everyone can access it. Yeah.
One second. Yeah, I sent it.
Okay, I think everyone can just download it via chat, or we'll just send it over on the group as well. So you can see it there as well. Okay, so thank you. Hope everyone had fun. So,
Thank
okay.
you.
See you all next time.
Yeah, thank you so much, everyone. Have a nice one.
Yeah.
Yes, bye.
Bye.
Bye.